All right, so yesterday we talked about how to solve inequalities. We did some pretty simple ones. Today we're going to do some pretty simple ones as well. All right, and then slowly throughout the week and next week we're going to progress into a little bit harder. None of them are going to be terribly hard. None of them are going to be something that you already don't know how to do. Okay, so this should be pretty easy. Remember your instructions. We're going to solve them and then also graph the solutions. Remember, that just means put it on a number line. Okay? All right. So let's say we have, and today I'm going to change it up a little bit. Yesterday it was just kind of adding and subtracting. Today we're going to put some other operations in there, multiplying and dividing. Let's say we have x over 3 is greater than or equal to 4. So when we're solving these, you solve it just like if this were an equal sign. What's happening to x? It's being divided by 3, so we want to do the opposite of division, which is multiply. We would multiply both sides by 3 to get rid of that. X is all we have left over there. Bring down your sign. And then 4 times 3 is 12. So remember, the difference between these and the other equations, in the past it would say x equals 12. That's the only thing x could be. Now we're saying x can be anything greater than or equal to 12. To graph it, 10, 11, 12, 13. To graph it, what kind of circle do we put on 12? Do we fill it in or no? Fill it in, and then greater than would be that way. Okay, now think about this. I want you guys to think about what this means. X can be anything from here and over. The arrow indicates that it goes for forever. How far do numbers go this direction? If I keep going, they go forever, right? 13, 14, 15, 16, 17, blah, 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 100, and just keep on going, okay? So x can be anything in this area. Let's check ourselves on this, okay? So we're saying x needs to be anything greater than 12 or equal to 12. Can y'all give me a number, any number you want that's greater than 12? 15, all right, he picks 15. So we're going to plug 15 right here. 15 over 3 is supposed to be greater than or equal to 4. Well, what is 15 divided by 3? 5. Is 5 greater than or equal to 4? Yep. And he picked one that didn't give us a decimal. If he had picked 16, 16 divided by 3 would have been 5 point something, but that's fine. Still greater than 4, right? Okay. So we're not going to check ourselves anymore. Just wanted to do that for just the purposes of doing it one time. All right. Like I said, not very many of these. What if I have 36 is greater than 4x? And we want to solve it and we want to graph our solution. Remember, yesterday I said, where do we want x to be? We want it to be on this side, the left side. When it's on this side, it is on the wrong side. So before you do anything, flip-flop your whole problem, okay? Literally just switch 4x and 36. And when you do that, what do we do with our sign? You flip it as well. So it was pointing at the 4x, it needs to still be pointing at the 4x by flipping that sign. Now this should be an easy one for us to do. 4x means 4 times x, right? So we need to divide by 4. And then 36 divided by 4 is 9. So x can be anything as long as it's less than 9. Quick graph. 8, 9, 10, 11, blah, blah, blah. What kind of circle are we using here? Open, and then less than that way. Make sure, I cannot stress this enough, make sure that you flip your problem first. Try and get that done, and then you're good to go. All right, let me give you guys about 3 to try, and that's probably all we're going to do, because how many of these do we really need to do? If they're this easy, it can't be that bad, okay? So let me give you guys 3. Let's see. I'm going to do some with some negatives. Let's do x over 8 is less than negative 3. Let's do 21 is greater than or equal to 3k, changing my variable. And then one more. 1 is less than or equal to x over 10. Okay, so y'all try those 3 real quick. Solve them, then graph them. Okay. So, is x on the right side? It's good, right? It's on the correct side. It's over here, okay? So we want to get rid of the 8 by multiplying by 8. That gives us negative 24. So x needs to be less than 24. I want you guys to keep in mind, this is the answer, okay? This is the answer. X needs to be anything less than negative 24. The graph is just another way to show the answer. Now, technically negative numbers go the other direction, so it would be negative 23 here and then negative 25 there, but I give you a number line on the worksheets, okay? So I'm not super concerned with that. We're going to do an open circle, right? And then less would be that way. All right, for example 4, is our variable on the right side? No. Needs to be switched. So just take this whole thing and this whole thing and just flip-flop them. 3k and 21, and then this is pointing at the 3, so I need to point it at the 3. Flip it around. Now, easy one to solve, divide by 3. K needs to be less than or equal to 7. That's my answer. K can be anything less than or equal to 7. And then on my number line, 5, 6, 7, we're going to do a filled in circle and go that way. And then our last one. First thing, flip the problem around. X over 10 and 1, switch those two guys. It was pointing at the 1. We need it to be pointing at the 1. We're going to multiply by 10. What's 1 times 10? 10, right? So x needs to be anything greater than or equal to 10. And then on a graph, 9, 10, 11, we're going to fill in our circle and greater than. Okay, that's it. Again, I'm probably taking it a little bit too slow because we